Hello everyone, sorry for a little wait. Today we start chapter 2 of our bootcamp, and we will move on to object-oriented programming. And the first lesson will be about encapsulation. Just in case, before the lesson, I'll post once again, because I see the stream isn't really announced for some reason. Let me announce it. Where is it? All right. Chapter 2 OP lesson 1. And yes, that's a good idea. I should tweet it or something. Do you guys hear me well? Is the sound quality fine? All right. Copy. Okay. So here are the slides. So again, we're going to start the chapter for object-oriented programming. And today is the first lesson. We'll talk about encapsulation. We will today the whole chapter will consist of each of parts for object-oriented programming. That means encapsulation, inheritance, polymorphism, abstraction, and object-oriented design. And we'll also talk a bit about the paradigms that evolved to what we have now, to OP. And for this lesson, we'll talk about the history of paradigms, about what is OP, why do we need it, and fundamental pieces that make object-oriented programming the most important piece, I think, which is encapsulation. I will not cover 100% of it today. I mean encapsulation. I won't talk about one main part of OP in C#, specifically in C#, because I want to leave it to C#, to the course, to the chapter 3 when we start talking about it, so that you get a better understanding. But you'll see what I'm talking about soon. So, history of paradigms. It all started from machine code. And machine code essentially was ones and zeros. Ones and zeros because that's the code that machine understands. That's what all modern languages compile down to, so that a machine can optimally understand what is written, and that there is no extra translation needed for a machine to understand what we want it to do. However, a human to write ones and zeros, it's pretty much impossible. And thus, the first ever programming language was assembler. And assembler was essentially a bunch of instructions for memory manipulation that would directly talk to a machine, but through kind of a human language. So you have instructions, very short instructions, you directly manipulate memory, and you move memory into certain places to do certain things. extremely hard to make, but surprisingly, assembler is still used today when performance is critical, because you write exactly what machine understands directly, and so there is no translation needed, and so it's extremely potentially fast. You cannot, if you write perfect assembler code, you cannot go faster than assembler. However, there was another paradigm close to assembler, after assembler, which was called functional. And the thing about functional paradigm, it developed from mathematical way of thinking, that everything is a function. That a program is essentially a bunch of functions communicating with one another, and only within a function a state like input is allowed to mutate into something else and be mapped to some output, and nowhere else. You don't change state outside of a function. Everything is in a function. And some languages, such as Haskell, pure functional programming language, doesn't even let you mutate state of a program outside a function. Everything has to be inside a function, and there is no concept of just data, like data with attributes. I mean, there is that too, but it is supposed to be changed inside a function. Procedural was almost as at the same time as functional programming, but it branched basically. They are both branches, different branches. So what procedural code means, that you have one global state and a flow for your program, which is very linear and quite easy to read, I might say, but it's a lot of copy pasting, and there isn't much thought involved in code. It basically is code to make it work, and such code is still used today. For example, in scripts like PowerShell and other, it's useful there because it's just making stuff work. There is no need for fancy patterns for simplicity. You're just making it work. Anyways, about functional, one more thing. Functional programming is very popular to this day, probably on par with object-oriented programming, and it definitely has room for solving certain problems, especially problems which are well defined by mathematical models such as machine learning, artificial intelligence, data transformations, analysis, and stuff like that, where there are no well-defined models. So procedural, just global state, and procedural code finally evolved into object-oriented code. So here we have a state, a flow for a program. And the difference in object-oriented programming is that we still have the same flow, but everything happens inside an object, a class. The difference between procedural code and object-oriented code is that in object-oriented code, we have a local state, a bunch of small states instead of one global program state. So object state instead of program state. And like in functions, we have everything done within a function. So in object-oriented programming, we have everything done in an object, in a class. And OP is extremely well to be used in enterprise applications, in games, and in many other areas, but in those two in particular especially. So let's move on to what an object is and what a class is. So how does an object looks like? So let's start from an example. We have a person class, and a person class has the following properties. It has a name, height, weight, age, and contact, and that's pretty much it. And to build a person, we need a name. To define a person, every person needs to have a name. That's the minimum. So what do we have here? We have a class person. So person is the class name. And this class has the following attributes, the following fields. And it has a constructor, basically a thing that tells us how we can build this person, how we create a new person. And we have contact info, so an object, a class, can have another class within it, another object within it. So person has contact info is a class, and contact info has address and phone. So a person has name, height, weight, age, also address and phone. Don't be intimidated if you don't understand what's written here. We'll cover each piece step by step. This is just an example. So we have a class that defines a bunch of data, and we have now a bit extra in this class. We have also a function. So just like in our static classes, we couldn't define functions, we can define functions in non-static classes as well. And so we have a function talk. So a person can talk, and he prints a message to console when he talks. So now we know that classes have data, and they can have methods as well. And the beautiful part about objects is that we can create multiple of them. So you can see here we created Tom and Agnes, two objects. And we called talk from Tom object to print hello world to the console. So what this does is that it just created two objects and assigned a name to them. Tom has a name Tom, and Agnes has a name Agnes. And I know there might be some questions, but I will try to answer those questions with examples. So here goes. Basically, object-oriented programming is thinking in objects. Everything is an object, and everything can be explained or defined by answering 3 questions. So we need to answer a question: what is it? What data does it hold? And what can it do? What is it? What data does it hold? And what can it do? So in our example of a person, we have a class called person. So what is it? It is a person. It is a person class. What data does it hold? It holds name, height, weight, age, and contact info. So that's the state that this object will have. Every person has its own name, height, weight, age, and contact. And all those things are called fields. variables within a class are called fields within a class scope, within this scope. A class, just like a method, has to have a scope. Everything really in C# that holds something has to have a scope. So you can see these are the bounds of this class. And so what can a person do? We said a person has method talk, so a person can talk. And that's how a person talks. Potentially, every person talks in their own way, but in this example, every person talks in their own way. And we have a rule that every person needs to have a name. Without a name, person has no meaning. So here we defined a constructor. By default, every class has a constructor because we need some way of building an object, of creating an object. And of course, we can implement our own constructor. So implementing our own constructor adds a constraint on a class. And in this case, we say that a person needs to be created by giving it a name. So if I create a new person, I'll pass it a string, a name. If I don't pass a name, I cannot create a person because there is no constructor accepting no parameters. I can have multiple constructors if I want. So like I mentioned, every class has a default constructor if no other constructor is defined. However, if we define our own constructor, like in this case, default constructor loses its value, it disappears basically. And if you want your own default constructor, you'll need to implement it yourself. Basically, just write a simple empty constructor without any parameters, and that will be your default constructor. So in the person case, that would mean that I no longer need to pass string name, and the insides of this function, of this constructor, will be empty. So to create a new object, we need to use a new keyword. New keyword allows creating a new object. And each of those objects will have their own reference and their own state. There was a question, fields are uppercase, and the answer is not really. Fields are not uppercase. They're not uppercase, they're not Pascal case. In this example, yes. But normally they're not, and you'll find out why in practical examples when we move on to LiveCoding. So, as I mentioned, when we do new, when we create a new object, so we have new keyword, with it we can create new objects. And new objects have a reference, a new reference. And you already are familiar with the concept of a reference when you created an array. And the key thing, when you created an array and you change an element at a certain index, the array itself remained, I mean, if you change that within the scope of a function, outside that function, the changes to array remained. unlike the changes to a variable, to a primitive like string, int, or bool. So when you pass an object to a method, and in this case, let's say we have namesRegister, a namesRegister class can rename a person, giving it a new name. So if I pass a person and give it a new name, outside this class, outside this method, the new name will remain. So if I create a new person and call him Tom, and then I say namesRegister rename Tom to Jim, after I do a rename, his name, the original Tom's object name, will become Jim. And it will print Jim if I do console write line. So now let's go back to where we started. We started writing everything static because we didn't know a concept of an object. So basically, static fully applies to what non-static fully applies to what we already know about classes, what it can do. So class can have data and it can have methods. Static simply lets us keep a global state of our program. And what I mean is that within a class, whatever is static is shared across the whole class, the whole program. So you cannot have multiple statics of the same class. So static essentially prevents you from creating new objects in a class. So I cannot create a new instance of a static class because it doesn't make sense. Static means one, unchanging. Well, changing, but with a single state. And so a static field means that it's shared across all instances of a class. I can have a static field in non-static context. I can have a static field in a non-static class. That will work. But that just means that if I change that field within an object, then the change will ripple across all objects. So you need to be careful about using static now. And in fact, in the upcoming homework, I'll encourage you not to use static. So if a class is static, you cannot have non-static methods or fields. So a static class must have everything static in it. And now let's talk about encapsulation. Encapsulation is literally a capsule. So within a class, we group very tightly related data and actions. So methods and variables that are very tightly related will be put in the same class. And it's really a very good definition, not definition, but name for this pillar. So encapsulation means data hiding, and also it means grouping related functionality and data. And like I said, we hide stuff with encapsulation encourages hiding stuff, and therefore language design is done so that everything by default has the lowest possible access modifier. Access modifiers, for now, all you should care about is public and private. So access modifiers prevent you, allow or block other pieces of program accessing different pieces of code. So if a class is non-public, I won't be able to access from another assembly. For example, if console class wasn't public, I wouldn't be able to call it from my own program. And in this case, you can see I have a private constructor for person, and therefore it's impossible for me to create a new person because the constructor is private. I cannot call it outside the class. Private means you cannot call it outside some scope. And private for fields, for variables, for functions means that it's not accessible outside the class. So private means it's not accessible outside the class. And it's best practice to make everything private if you can. The less the reader, the consumer needs to care about your code, the better. Reduce the noise if possible. Here we can see how to create a new person again, but look at what type we assigned a new person to. We said that a new person is an object. In C#, everything is an object. So I can write pretty much object and then name the object equals to pretty much anything. So I made a mistake. So it's object A equals 1, not object int A. So object Tom is new person, object A is 1, and whatever I can come up with, it's an object in C#. I can convert anything to an object. So the benefit of this is that I can treat it in a general way. I can treat everything in a general way because everything is an object. More details about this in chapter 3 when we talk about C# in depth. When we talk about encapsulation, it's worth mentioning that we often mix access modifiers. We often need to provide different access for data itself for different fields. So for fields, so data such as name can be read or written. I mean, I can set a name or I can get a value of a name. And in object-oriented programming, it's best practice to never have public fields and to always expose data through methods instead of variables within a class. And this is done through setter and getter methods. And the benefit of this approach is that now we can mix access modifiers for reading and writing. We prevent, we can also do a bit more when getting or setting a name or data. For example, when I get a name, I might, print that I'm getting this name, or when I set it, I can print that I set the name. So it's a convenient little trick to not only have data written when I call set name, but to also do something on top, such as printing it. And the third benefit is that getter and setter methods prevent data mutation. And I won't talk much about data mutation now, but I'll just say that there are ways that you can, if you're not careful, you can put stuff through such programmatic syntactical ways that it becomes extremely hard to track and maintain. And getter and setter methods really prevent you from doing that. It covers that thing, and it doesn't let you treat data recklessly. So that's the third benefit of why you should be using getters and setters. So when you are working with objects and you want to get or set publicly, emphasizing publicly, objects data, you should do it through functions, always. Always, in 99% cases, always. So back to the question, what naming scheme do we use for fields? Fields are private, and we name them with an underscore. The first symbol for a field will be underscore, and all fields will be private. And methods are camel case. Fields with underscore, but only for first symbol. The rest is camel case. Not Pascal case, camel case. We start with non-capital letter after the underscore. And underscore is used because when we pass stuff in a constructor, so or a method. So for example, I pass a name in setName method, and if I passed a name, if my name field didn't have underscore in the name, then I would have ambiguity. I would say name equals name. What does that mean? I need to work around this issue. I need to do some unnecessary complexity to make things clear. And instead, I could simply say underscore name equals name. And this solves the ambiguity issue. A few more things before I end the theory part. So there is some terminology that comes with a class. Functions within a class are called methods, and variables in a class are called fields. And fields, constructor, and methods are called members, class members. So method for class functions, field for class variable, and member for pretty much everything that is within a class. And to sum the theory part up, why do we need OP? And the answer to this is that it makes complex program state simple. We no longer have a global program state. We have minimal noise and many small internal object states that are never exposed directly and that are abstracted through methods, exposed through methods. And this way of thinking in objects, allows us to think in concepts. Everything in the world can be portrayed as an object. A cloud is an object because it can have a color, height, probability of rain. A house is an object because it's made of rooms, it has inhabitants, roof, color, and so on. A person is an object because it has a name, it can talk, it has an age, it gets old. Everything like that, otherwise complex, can be expressed quite simple using objects. And now some questions. Nevin asked, on slide 23 you have underscore name equals name. Should this be name equals underscore name, or you're setting the private? So to answer that, as you can see here, the data is actually stored in underscore name. So name is a parameter and underscore name is a field. So I don't want to set parameter to default value of underscore name because that wouldn't make sense. I want to change the state of a person. So I change underscore name to a new name I pass. I hope that answered the question, Evan. Mihail Fox asked, what about properties? So just like for the before, you were not exposed to lists, you're using arrays. So you also be using setter and getter methods for now instead of properties. You need to develop a habit that C# is exclusively giving you access to properties, and other languages don't have that really. But you need to understand why we use getters and setters nevertheless, and not be spoiled by properties. So we'll talk about properties in chapter 3 when we cover C# specifically. Then basically you'll learn about all those things in particular. Joshman said there is no difference between a property and a field. And I strongly disagree with that. A field is a variable. A property is a method. That's a major difference. So a property is setter and getter methods, and a field is just a lump of data, and that's all. Semantically, if you call a field and a property, you won't see any difference. But that's the only similarity. Only the semantics outside the class scope. But other than that, it's very different things. All right, let's move on to Visual Studio. We will have a short break, 2 minutes break. I'll go drink some water, and I give you some time to also do whatever you need to catch your breath, to process all the info, and we'll continue in 2 minutes. All right, I am back. I hope you had a little rest. So let's do some examples, some interesting experiments in C#, Visual Studio for object-oriented programming, and let's cover the concepts, the pitfalls as well, that we talked about. So first thing, every class is supposed to be in a file of its own. So it's still a mistake of students to too often use a program class, everything in a program class. You should try getting in a habit splitting stuff into different files, keeping the files small, keeping classes small, and putting everything in a place of their own. So, in our previous homework, we had people and their balances. So let's turn that in an object-oriented approach, shall we? So we have a public class person, public, because I want to call this outside of this project potentially. So my class is called person, and I define a constructor for a person. I say that every person needs to have a name. And this is the data that a person has, a name. And my name is equal to the one I pass from constructor. I need ways of setting a name publicly, getting a name publicly. But I won't have a way of setting it. My name is read-only. Publicly, my name is read-only. I'll actually put a read-only modifier as well. It's a modifier which means almost like a const, but the value can vary. It just means that I can only set it from a constructor, but nowhere else. That's what const read-only means. So I have a name which I cannot change, and I can only get a name. Let's play with this. How do we create an object? How do we guys create an object? There was a question from Aurora. Is it good practice to have constructor as the last method in class? The answer is normally above constructor you'll have data, below constructor you have methods. Normally you wouldn't be using getters and setters as methods, but as properties. Therefore, I still put those above the constructor. I am not sure of the convention. I think it's mixed convention. Some think it should be above, some think it should be below. But if I have a new method, such as talk, then such method will be under constructor. So above the constructor we have data and strictly getting, setting, data related stuff. And below a constructor we have methods, normal methods, which tell what an object can do. This tells what an object, what data does an object have, and this tells what can it do. So the constructor is actually the first method of a person class. So below fields, above methods. This is also a method, but you won't normally see getter and setter methods. Thus, you put constructor below data and above methods. And I call getName also data because it's very tightly related to data. So let's try it out. We created a new person and it has a name. So I say person, new person, and I give it the name. Kaisenel. Hey, it's me. And if I print the person's name, it will be Kaisenel. Now another question. Also, it was answered that there can be multiple constructors. Is that something out of scope of the current lesson? No, that perfectly fits the current lesson. So, what if we don't have a constructor? As I mentioned, if we don't have a constructor, one is made for us by default. So, you see, this is no longer valid. However, if I do this, very similar to array initialization with those brackets open, because this is called object initialization. I cannot set a name, so I cannot really achieve what I achieved there. So just for the purpose of this lesson, I'll put set name, name, void name. Okay, so now I made name to be no longer read-only, but I can also write it, right? So only this method makes it read-only. Only this method makes it write-only. So here I can say set. Well, I cannot say anything here because it's a bit different thing. I can only do set name now. Again, I don't expose data directly. I do everything through methods. So this is equivalent. Julian asked, what do you think about the value of classes with private setters and the only way to modify the properties through the method? Is that good practice way? Okay. First, let's explain the difference between the two things. Let's continue with two constructors, and then I'll explain the question, the answer, and give the answer to that question. So before we had a constructor which accepted a name. Now we have a constructor which does not accept a name. In fact, we have no constructor. So if I run the program now, you can see that it still printed my name. So it works. How does it work if I have no constructor? You see, if I try to go into the method, it just goes to the class. And what this means is that every class has a default constructor. And default constructor is an empty constructor. So let's implement a default constructor as a proof that it exists and that we know how it looks like. So an empty constructor looks like this. We have a class name, and we call the class name with as if it was a method with brackets ready to pass something, and that's our constructor. So here we call the constructor, just like we would call a method, and we create a new person. And we set its name here, and we print it. So again, it's exactly same output. Now the question was, how do we create two constructors? By simply adding a second constructor. So now I can have two people and print both of their names if so I wish. So you can see I just called two different constructors. So all it took me to add one extra method. You see, one method, second method. And this is called constructor overloading, method overloading, whatever you call it. I think I didn't really cover the overloading concept, but it basically means that you have method with the same name, but different variables. And thus, by passing different variables, I call different implementations. So as long as my variable declarations in the constructor are not ambiguous, it'll mean I'll be able to call the implementation I want. So here, I don't set anything, and here I set the name when creating a new person. And as Joshman said, I said by default, every class has a default constructor. So if you didn't define any constructor, you'll have this one at the very least. However, if I comment this constructor out, let's see what happens. So I commented the quote-unquote default constructor, and you see now it says there is no argument given that corresponds to the required formal parameter name of person string. What happened? The thing that happened here is by commenting this constructor, I no longer have a way of calling a constructor without parameters. So this means that by implementing your own constructor, you hide the default constructor implementation. It's no longer used, it's no longer needed because you implemented your own. So you don't want both things if you have one already, right? Because you want rules, domain rules to be applied to your constructor, to your class. So I cannot have, my domain says, my business rules say, I cannot have a person without a name. Thus, it does make sense to pass it in a constructor. It constrains that every person has to have a name. This does not add a constraint, so don't abuse this. Don't spam constructors where you don't need them, because it is a workaround rather than a clean solution. It does make sense in some cases to have a default constructor, but in most cases you want to define how you create objects. What needs to be passed to create the initial object? I create a person from a name. What about if the arguments are the same in two constructors? So if the arguments are the same, so you mean this? Well, you cannot have duplicate declarations. But if I pass this, that I pass, a different type of argument, it works. It works perfectly fine. I can mix types. So as long as types are different, as long as number of parameters is different, there is a difference and I can call it differently. But if it matches in types, then I cannot have multiple constructors or methods. Now, Julian asked about does it make sense having private setter and getter methods? So what he refers to, does it make sense if, let's say, let's create a few things to make this meaningful. So I have surname. So person also has surname. I like grouping it like this. So a person has surname. Set surname. And I pass string surname. Whoops. So surname is surname. And I can also return surname, get surname. Public string get surname. Return surname. So now a person has name and surname. I don't have to pass surname when I create a person. That's not a rule of my domain. However, I want to, if I need to do that, I want to set a name when I create a person. So I created the first person and I set its name to, not name, but surname, to C#in. And I'll do the same to this person. I actually won't do the same to this person. So for person 1, I set surname to C#in. For person 2, I do that. Now let's print the full name of a person. Get surname. And let's do the same for this one. I'll just copy it. And it's person 2. So here's what happens now. So I managed to successfully set a name of the first person, and for second person, obviously it had no name, it was default, it was null, and thus no name was printed. So only first name was printed. However, this logic is redundant and it needs to be put in a function. So what function should I use for surname? And the answer is I should use simply a getter function. So public string get full name, because that's essentially full name. And the thing that I return is those two things. And now I don't need the person, because I am inside a person already. And here is a really nice thing about objects in general. You know, when you're calling functions, when you're calling object explicitly multiple times, something from an object, it might imply that it's not the place for calls. For example, if I want to print a full name, I call persons get name and get surname methods. And if an object can manage its own state without third-party interruption, without second-class interruption, it should manage its state by itself. So I can simply print full name by combining those two in yet another object, a method in an object. So look how much prettier the code becomes. It becomes very fluent, natural to read. So all the rules are within the object itself. It can manage, thus it can rule itself. Now let's go back to the case that Julian asked about. So I will hide, I'll hide something. I will prevent setting name publicly. It's against the rules, but I can still set it internally, for example, right? And Julian asked, do you use setter and getter methods if they're private? And let's think again about why do we use setter and getter methods. First reason was to mix access rights, that we wouldn't expose read and write to the public. Since we do need to have a field in order to read it or write it, that doesn't really make sense. So the first point is denied. The second point is, well, maybe we want to do something when we read and write. That is true, we might. But the point why it's convenient inside the setter and getter methods is because we expose them publicly. So we might, when setting a name in hundreds of places, set the name, and in hundreds of places we'll need to write something on top of setting a name. However, if we had a method, instead of 100 places, we now have one. However, if we need to do something on top of setting a name in private scope, in class scope, that means that we will manage our own scope. Everything is in the same place. And so setting a name and doing something on top still has benefit. If I reduce code duplication, I'll use it. I'll use the setter. But I won't use it if it's under 3 places that repeat itself. Just like I wouldn't make a function for code that is under two repetitive parts, unless I'm very pedantic and feel like refactoring code. So private setters don't have much purpose. And the third point, data mutation, again, it's invalid because you do have your data as raw in field. So setter is not needed as much as public. Private setters and getters are almost not ever used in object-oriented programming because they don't encapsulate anything. It's just a method at that point if you use it as a, well, it's just a method semantics at that point. No longer encapsulation. Has nothing to do with encapsulation. So I hope that answered the question, Julian. Questions. Catgirl Aurora asked, public static person from year, string, name, int, year. Right. So the question was from year, can it be static? Should it be static? Probably not, but the key point here is that from year has nothing to do with person. So it would go to a different class altogether. I'll go to Alice OP's question. Hey, can I ask, why do we set the variables as surename underscore and then reassign them to surename inside the class? Right, Alice. Your question was, why do we assign, why do we set variables as underscore surname and then reassign them to surname inside the class? So the answer is we don't reassign them, we just assign them once. So like I said, we don't expose anything ever directly as is in terms of data. So we don't expose data publicly, ever. So we don't expose public name because we don't want to mutate it. We don't want to, we want to have an ability to mix reading and writing separately. And we also want to have an ability to do something on top when reading or writing. Therefore, we set it separately. I hope this answers the question. And we don't reassign it anywhere. We just set the name to the new name value. And the naming is underscore because it's two different things so that we avoid ambiguity. If it wasn't name with, I won't show that one actually. Next question. Joshman said that constructor should never be static. That's not true. There is static constructor, but that's a completely different thing. So don't worry about it at this point. We'll talk about this in chapter 3. So is there something comparable to a class method from Python? Like if a person had a name and an age and you wanted to have a constructor for person and that for person, that would be created given a year instead of an age. Well, sure. I mean, you can do whatever you want. You can have fancy logic. For example, it doesn't make sense for a person to have, you know, an age as a value to be set. But it certainly makes sense to have his birthday date saved, you know. So his birthday is date time. Date time is a type for dates. So I have date time and it's birthday. That's his birthday. So public void set birthday. So his birthday, well, his or her birthday is at this date, time, and I can also get it. So I return birthday. However, here's the thing. I won't need those. Birthday doesn't change, and I don't need to get birthday that much, to be honest. All I want is age. So, answering your question, I'll pass in date time, which is birthday. And I set it here. Now, here's the thing. This is my birthday. And if I go here, there's nothing I can really do with it. Like, there is no data that I can access, and I don't have a method for birthday. However, what I want is to be able to have age. So how do I get age when I have birthday? And the answer is quite simple. This is not a real algorithm for age. But again, get age. I get my age by calculating it. So my age is a difference between current date and my birthday. I take it and I say, what's the difference in years? Talk Total days, well, total days divided from 365. So that's my age. Total days, double. So it's an integer. Wrong brackets. So here you can see how we get age of a person. So I don't need to have, you know, a static hard-coded age that doesn't change based on date time. Therefore, I have get age method. So now if I want to know the person's age, I can. So I'll say this is person 1, get age. And when I create a person, I need to give him a birthday. So my person's birthday will be, I'll give it my own birthday. So May 25th is my birthday. And let's give it, well, for that one we don't need. And set name is no longer used. So if I run my program now, you can see Kaizenel C#in is 25. So we implemented an age based on birthday. So I hope that answered the question, Aurora. From the, we're not doing properties because it's a concept that's not well explained. I think if you ask 90% of C# developers, why do we use properties? Most of them will say that that it's because we can mix read and write, or that we can also do something when we read and write stuff. But the answer is not that simple, not that straightforward. There are more reasons than that, such as data mutation and being future-proof. So I really want to encourage people to get used to setter and getter methods, then to get a feel of how does it compare to a property and why C# is such a nice language. And, you know, so that it's not that much of a shock when in case they switch languages such as Java or Python or C++. Catgirl Aurora, didn't I just have the example of alternative constructor or a method for a class? I'm not sure what you mean. Because this looks like exactly what you want, what you're talking about. I mean, I implemented a method which doesn't directly, you know, have an age, but gets age based on birthday. And I also didn't set age directly, but it's based on birthday. So this, and when we have multiple constructors, so this looks like yes, birthday age, but What example were you having? Okay. I hope you succeed. I won't bother with that anymore. I'll just give a few comments to this one. Parameterized constructor. Also, get used to CTOR, short for constructor. This is a default constructor. Every class has one unless a custom CTOR is defined. All right. And lastly, that thing where we want to say something about the person. So we just say a message. And I'll say a classical message. I'll say person1, hello world. So if I print this now, the person says hello world. Do you guys have any more questions? If not, we'll move on to Kahoot. So go to here. Still waiting for some people. Not everyone is here. I hope so too. And I think we can start. Good luck. So, is OP abbreviation the same as object-oriented programming? Yeah, sure. Easy peasy. The static class cannot have a constructor for creating new objects. It cannot have a constructor for creating new objects. A static class cannot create new objects. It can have a static constructor, but that's not for creating new objects. That's just for creating initial static class state. About that in chapter 3, but static class cannot have a constructor, guys. One for all means static. So we cannot have a constructor for creating multiple objects in static class. Class is a blueprint for objects. Is that true? Yes, of course, because it defines 3 things about an object: what it is, what it can do, and what data does it have. By default, class members are public. Is that true or false? By default, class members are private. You cannot call a method from a class if you don't explicitly say that it's public. What is a class member? Yes, so it sounds like familiar, maybe natural even, but member is essentially everything that the class has, all the pieces that it has. So all the methods, all the constructors, all the fields. In order for a method to be called from outside a class, it needs to be yes, we only call public methods, not private, not protected, and certainly not secured. Secured is a made-up word. Protected is a keyword that we'll be learning a bit later in the next lesson, actually. But public is what we'll be using for most of the time. For calling stuff outside the class, not most of the time. Which of the below does not justify the use of setters and getters? So, does not. It means some of those are meaningful for setters and getters, but one of those can be done without them. And just to do that, we don't really need setters and getters. So which one is it? Wow. Wow. So the second one is true because there is no other way that you can achieve reading and writing, only through setters and getters. So the second one is definitely explained in the lesson. The third one, it's a method. So if we want to do something extra while reading or writing, we can only achieve that through a method, a setter or getter method. So third one is definitely not the right answer too, because it's justified use. And I mentioned a few times already, but not enough obviously, that it does prevent data mutation. We'll talk about later in chapter 3, but it does prevent data mutation. I won't go into detail, I'll just mention that. So the first one, we can change object state without a setter and getter, and that's perfectly fine, but it violates principles and puts us at risk. But we don't we don't use setters and getters just because of that. Oh, nice. Great. Next. So, which of the following is false about constructor? False. Yes, so every class doesn't need to implement one explicitly because by default every class has an empty CTOR. And it's true, every class has at least one. the default one, unless you implement, but that's still one. And it is indeed used to create new objects. Fields and methods store data. Is that true or false? And the answer is false, because fields are for data, that's true, but methods can have different purposes than just setting or getting data. So it's not really. What is encapsulation? That one is not ambiguous, I think, I would argue. What is encapsulation? This question has, well, you'll see, but it's a bit different than what I wrote. And both answers are correct. So both who picked those two are correct. It is data hiding, but it's also putting that data under a single class, data and classes, how you group them, how you determine what goes under what is also part of encapsulation. Putting everything into a single class. It's not object state mutation, that was just a random thing that I wrote, and it is not methods hiding, because we expose stuff from methods, we don't hide methods. Can you call a default constructor if you implemented a constructor with parameters? Well, I read the question a few times and I read the answers I wrote, and I do think that it makes sense if you read this carefully. So let's go through the wrong answers. So if you implement a constructor with parameters, and that's all that it says in the question, that means that the default constructor, the constructor that has no parameters, is no longer available. So no, you cannot call it if you don't do anything. So yes, the default constructor remains is false. So 5 people made a mistake. And the answer that goes, no, the default constructor is hidden and cannot be called, would be true. But the formulation is absolute. Like, there is things that you can do to expose it and call it still. So I think that the second option potentially could be picked, and that's an okay answer as well. But I was expecting something else. Nobody picked the third one, so I won't explain it. It was a random bullshit answer. And the fourth one is, of course, if you implement a constructor without parameters, which does nothing. It's basically a default one, like we did with person. I agree that blue one is as accurate as the fourth one, to be honest. I think both should have been marked. With empty body, if I add it, then this would be correct for sure. Now, last question. Can a static method be called from an instance of a class? And I'm surprised that many of you put true. Instance of a class means that I create an object. And to call static methods, I don't need an object. I can only call them from a class, not an object. I'll show that. So let's say we have public static get string get class name. You can have a static method, but you cannot call it from an instance of an object. You'll need to call it from a class. So for example, this makes kind of sense. So if we do something like person1, you see there is no get class name, and I can only get class name through a person class. So that was kind of a tricky bit. Yeah, so if you have a static method in a non-static class, it makes no sense to access that static method through I mean, the question though is clear. Can a static method be called from an instance of a class? So I just tried to call a static method from an instance of a class. My class is person, person1 is an instance of a class. And I cannot call a static method from an instance of a class. And for this one, I cannot call it from an instance of a class. However, I can call it from a class itself. That was the tricky bit. And now the winners. Mikhail Fox, third. Royaloff, second. And Catgirl Aurora, first. Resho, fourth. And Alice, fifth. Well done. Hype, 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 please. PogChamp, hype. Yeah, the MVP Kahoot player. What else? That's it for this lesson. And the homework for this lesson will be first, the question. If you are inside a class and have methods of a class, x void f g and static void g and main XA, new XAF. Then the instance of a called, I don't understand the English. Then the instance called a method, a static method. I don't think so. Then oh, the instance A called a static method. No, it did not. In your example, you call F. F is not a static method. If you call G, you won't be able to call G. So I don't see your point. You cannot call static void G from A because it's a static method. Maybe in some languages you can, in C# you cannot. The context is C#. Right, the homework, guys. The homework is quite simple. If we go to okay, so what Aurora showed that we called F with parameter that gets returned from, no, that's also, it's not the same thing. Can you call a static method from a non-static, from an instance? I see where you're going. But I still remain to the same answer. I agree that I could have formulated it even better, but under the hood, you're still not calling it from an instance. So I still remain that if you have a really good understanding, the answer remains the same. It's not calling from an instance, it's simply calling from a class. Now, the homework is very similar to homework 7. And this is actually, so in homework 7, homework 8, I think, is a better one. Homework 8, not homework 7. The one with dirty file. Yeah. So your homework, the first homework for object-oriented programming is to clone chapter 1, homework 8, and not this specifically branch, but your own homework branch. And you need to redo it using object-oriented programming. So no longer you use everything static, but now you use objects and functions within those objects instead of everything that is static. So let me write it down. Where is it? Homework. There will be a branch, yes, but I will create it a bit later. You can start working on your current homework. The tests will change, but I haven't yet finished the tests, so it will be only done tomorrow or day after tomorrow. So homework 1. refer to this and implement the same homework using OP style. For now, I would say you just create a new branch from the homework that you already did and refactor it using classes, non-static classes and objects, and see the difference. And tomorrow or day after tomorrow, I'll change the tests so that they test no longer static classes, but they test non-static classes. So also kind of will make a structure for what kind of methods you need. So that's the homework. Yeah, and then merge to homework 1, chapter 2. That's true. Yes. So thank you guys for the lesson and see you next time.